So we're going to go ahead and finish yesterday's notes. This is part 2 of modeling periodic behavior. No one's listening because they're still talking about this apple party. Okay, we are. I'm going. I'm moving on as if people are watching. Okay. Average daily temperature of a city is modeled with this. Time is months after January. So that means like if time equals 0 is January. So because it's months after January, so 1 would be February, things like that. It says sketch this graph from 0 to 24. What just happened? Okay, yeah, right. Holly's being weird. First thing we have to do is sketch the graph. So what we got? We have an amplitude of 5, some kind of dirt or schmutz on my finger that I saw under the camera. Did I draw myself with a marker or something? It won't come off. There we go. Okay. So amplitude is 5, and our midline is y equals 20. It doesn't have a phase shift, so all we have to figure out is the period length. All right. Well, the period is supposed to be 2 pi over b, and our b value is actually pi over 6. You have 2 pi over pi 6. Keep, change, flip. 12. Anybody surprised by that? 12 months in a year. Yeah. But it's a little concerning though, because again, it says t is time in months after January. So again, that would imply that t equals 0 is January. But that means t equals 12 is January again? Yeah, I guess that makes sense. That's because that's when the cycle would repeat. Okay, that makes sense. All right, let's sketch this graph. Over 24 months, we have 2 period lengths. So let's say that's 24. Halfway through it is 12, 6, 18, and then half of those is 3, 6, 9, 12, 15, 18, 21, 24. Like that. All right, so what is our minimum? Our minimum is 5 under the number 20. So our minimum is 15%. And our maximum would be 5 above 20, so 25. And we already know the midline happens at 20. There we go, red pen. Cool. Time equals 0. Well, it's a positive cosine wave, so it's going to be at a maximum at 0. Maximum, and after 12 months, it'll be at maximum again. Halfway between maximums is a minimum. Halfway between a min and a max is midline. 1 period. 2 periods. There we go. Part B. Find the average daily temperature during May. So what does T equal for May? Is it? No, it's 4 though, because January is 0. So February, March, April, May, 4. Oh, I should have used pointers. My fingers are too fat. They filled up the whole screen. It's on YouTube forever. All right. So T equals 4. That's May. What we need to do is we just legitimately just plug in 4. And I would say this is a calculator question. I mean, we could do it by hand. 4 over 6 is 2 pi over 3. We could evaluate this by hand if you had to, but I don't want to. When I'm reading ahead of the question, find the minimum average temperature in the month. No, let's do the whole thing by hand. Let's see, average temperature when we plug in 4. 5 cosine, let's see, 4/6 is 2/3. 2 pi over 3 plus 20. Of course, I don't know my unit circle, so I will have to draw 2 pi over 3. It's in quadrant 2. Picture not drawn to scale. You know you were waiting for it. The over 3s are 60s. Let's fill it out. 1 negative because it's in quadrant 2. Root 3, 2. cosines x over r. Oh, so it's 1/2. X over r, 1/2. Ah, negative 1/2, thank you. 5 times negative 1/2 plus 20. 20 minus 2.5, 17.5. There you go. 17.5. C says to find the minimum average temperature in the month that it occurs. Well, what's the minimum average temperature? 15, yeah, so we just have to look to see at what month that occurs. It should be July, right? Because January is 0, so I'm counting on my fingers, not under camera, so we don't have to look through the pudge. February, March, April, May, June, July, yeah, 6. So minimum is 15 in July. How is the minimum temperature in July? This must be in the southern hemisphere. Even then it could be Celsius. Even then, it's got to be in the southern hemisphere because that's their winter time. Okay, and last question. What? Spring? But that's July though. It's in the middle of raging summer in the northern hemisphere. All right, last one, and we are done. Okay, at least we know where this one is. Madrid. We're in Spain now. What? Uh-huh. Yeah, I should be like, yeah, because Holly's got to watch the videos to just make sure I hide my fingers the entire year. Yeah. I'll have to learn how to write like this. Oh God, you can see him. Okay, so I do like. Okay, anyway, let's get this over with. So, on a hot summer day in Madrid, Antonio pays careful attention to the temperature. The maximum of 41.8 degrees Celsius occurs at 3:30 p.m. The minimum was 27.5 degrees Celsius. We need to find a sine function that models the temperature for that day. Is it? I don't know if that's hot. 41.8 degrees Celsius. Tell you what, after we finish the question, we'll actually look it up. So we have a period length of 24 hours. Well, we know the period's 24 hours. That means we can try to remember it's supposed to be 2 pi over b. So if you'd like to solve for b, you can just switch these two and you get that b equals 2 pi over 24, which is pi over 12. 107 degrees? Oh my gosh, does it get that hot in Spain? Yuck. Those poor people. All right. Yeah. Anyway, we know the maximum and we know the minimum. So what does that give us? If we know the maximum and minimum, what can we do with it? We can find the midline. How? Average, there it is. So our midline will be y equals maximum temperature plus minimum temperature divided by 2. Clearly a calculator question. Not going to even try. 34.65. That's the midline. And since we know the midline, what else can we easily get here? Amplitude, yep. Because our amplitude will just be, well, no, it would be the maximum minus the midline. $7.15 is our amplitude. And, oh, we're told when that maximum temperature occurs. 3:30 p.m. We need to convert this 3:30 p.m. to a time. Military time sounds good to me. So what would this be in military time? 15.5. Remember, there are 60 minutes in an hour, so 3:30 would be 15.5 hours after midnight. I think we're ready to rock and roll. I am going to sketch this because I am not very good at getting equations without a sketch. We're going to say time equals 0 is midnight, and we're going to say we know it goes to 24, right? Which is, again, another midnight. So here's 12, halfway between that, there's a 6, here's an 18, 3 in the morning, 9 in the morning, 3 in the afternoon. What's 21? 9? Yeah. 9 at night. There we go. Picture not drawn to scale. Minimum, 27.5. Maximum, 41.8. Midline, 34.65. And the only reason why I'm sketching is because it says to make a sine function. What we know is it's at its maximum temperature at 15.5. So that's about right here. So when was the minimum? Right. So if 15.5 is our maximum with a period length of 24, half a period away is where our minimum would be. So 15.5 minus 12 will give us 3.5. 3.5. And we'll say that's at 3:30 a.m. Again, are we surprised? 3:30 a.m., 3.5. So no. I put that dot as a maximum by accident. We said it was supposed to be a minimum. I have it way up here at the top. You can just ignore this. It means nothing. Not 100 degrees at 3:30 in the morning. It should have been way down here. Sorry. I don't know. So halfway between a minimum and a maximum is where we're going to have a midline hit. That means we need to add 6 hours to this 3:30 a.m. That puts us at 9:30 or 9.5. That point right there is at 9.5. And the reason why I wanted to see this one is because that is where the graph starts to look like a sine wave, because that's where it's at the midline and then heads up. So that shows us our horizontal shift. Picture really, really not drawn to scale. The point was I was looking for where am I at a midline heading up. That's what I needed to see. Our equation then is temperature against time of day is, well, it's going to be a positive sine wave. And we said its amplitude is 7.15. 7.15 sine, horrible 5. Sine of, we do have a horizontal shift, a phase shift, so I'm going to use brackets. The number in front of our, what's he looking for? Yeah, halfway between 3.5 and 15.5. Because halfway between a minimum and a maximum would be a midline. What was the number in front of what's our p-value? Oh, pi over 12. Horizontal shift is right 9.5, so minus 9.5. And vertical shift is 34.65. Get skinny math, you can do it. There it is. That's the whole thing. Now this question could have been made an IB question simply by asking, what was the first time of day that the temperature was blank? And you would have just done second trace intersect to figure out where that happens. But if it says first time of day, you're looking for a time on the clock. And those of you that are listening to that won't be disappointed when you see your test.